Hello, today we're going to talk about Docker. You really need to learn it. If you're working in IT, if you're a developer, or even if you're not professionally working as a developer, Docker is going to be really useful and you can do a lot of things with it. Traditionally, you're running an operating system on one computer and then applications on that computer. But what if you want to run more than one operating system instead of installing a second one? What you can do is run virtual machines. These are completely independent machines that run in your computer, completely isolated from one another, and each of them can have a different operating system. The operating systems that run on those virtual machines are not aware that they are running on a virtual machine. Those operating systems behave as in a real computer, which is a virtual one. For example, here I have Ubuntu running on this virtual machine, and here I have Windows 10 running on this other virtual machine. The Windows running here is completely isolated from everything else, and you can just test software, security issues. You can do everything you want in that virtual machine, and it's going to stay just there. What I'm doing here is what is called using an hypervisor. I'm using VMware Fusion here, but you can also use VirtualBox, which is free and open source. So what is an hypervisor? There are two types of hypervisor. Hypervisor type 1 is the one who installs directly on your hardware. So basically it has an operating system integrated into it. And then the hypervisor type 2, which is the one you saw me using, is the one where you have your operating system, Linux, Mac, whatever, and then the hypervisor is an application. The hypervisor, what it does is executes this virtual machine. So inside of every virtual machine, you have an operating system of your choice. In this case, it could be Ubuntu, Debian, CentOS, Windows, whatever you want. These virtual machines are completely isolated one from the other. And the hypervisor also emulates hardware. For example, let's say a network card or a sound card that you don't have in your computer, it could be emulated by the hypervisor. So you have a complete, let's say, a complete computer, basically, there simulated, virtualized for you to install any operating system you want. This sounds great, but there is a problem. The hypervisor consumes a huge amount of resources. And the reason is because for every single virtual machine, you have to install an operating system. Means there is a kernel for every virtual machine. There are drivers. There is all the hardware virtualization plus emulation that you have to provide for every virtual machine. And that's a lot of work for your machine, for your hardware, for the host, which is the one having the hypervisor. So all the guests have a lot of replicated stuff in all of them. Now, what if you don't really care that much about virtualizing the whole hardware to create a full virtualized computer? What if you are focused more on the application side of things? Can you virtualize the operating system instead of virtualizing the whole hardware, the whole machine? And that's the case for Docker. Docker is a daemon that runs in the background of your system, and the different virtual machines are called containers, and each container can have its own version of the same operating system as the host. It means that Docker, what it does is using the operating system where it's running already and sharing that, virtualizing that for the different containers. If you're using Windows, then you can virtualize Linux and Windows containers, because the Windows containers are going to use the operating system that you're using, the Windows host that you have, and the Linux containers are going to use something which is called the Windows subsystem for Linux. Now, if you're using Linux or macOS, you can run containers in Linux. And in case of macOS, it has internally a Linux virtual machine, and that is the one which Docker is going to use to virtualize the operating system for the Linux containers. To start with Docker, you can go to docker.com and install it on your desktop. There is a version of Docker for every operating system, basically for the major ones. And if you don't like to install anything in your computer, or you can't, you can also use Play with Docker. To use Play with Docker, you need a docker.com account, which is something anyway that is good to have because it allows you to also create your images. Where you can want to create a Docker image, you can upload it to the Docker app and make it public, for example. I like to have Docker installed on my computer. So let's start and create a first container. But for that, we need to pull an image. So let's create a CentOS computer, for example. So we type Docker, pull, we pull the image, CentOS. And this will go to Docker app and grab that image for us. Now let's grab another image, for example, Docker, pull, Ubuntu. And that's it. Now we have an Ubuntu image. Docker images is going to list the images we have. We have an Ubuntu and CentOS. Think about this. We already have 2 Linux distributions, images, download in our computer that we can use and create containers based on those images. And in those containers, we can create any application we want, test anything we want. This is really, really powerful. Now let's create one container using, for example, CentOS. Docker run. I'm going to call this my Linux one, and it's going to be based on the image CentOS. That's it. Now Docker container ls, and you can see here we have our container running. It's based on the image CentOS, has been created 4 seconds ago, and the name is my Linux. Now, what if I want to connect to this machine that is running right now? So Docker exec, the name that I gave it, my Linux 1, and then I say that I want to run bash. We are inside that CentOS computer. This is a CentOS distribution running now in your computer. Is completely isolated. If you're new to the command line, I have 2 videos about the command line in the channel, links below. With exit, we exit the container. Now let's create a container for the Ubuntu machine. Docker run my Ubuntu based on Ubuntu image. As you can see, I'm very creative with the names. Then Docker exec, and then we are going to connect to my Ubuntu, and we want to run bash. And here we are. This is an Ubuntu machine. For example, apt-get update, let's install Vim, for example. So updated apt-get install Vim, and this is basically installing Vim on this Ubuntu machine. Vim, here we are. We are running literally an Ubuntu Linux distribution in this container in the macOS computer that I'm using right now. Docker container ls. So here we have our 2 images running. Let's stop one image. Docker stop, and the name of the image, my Ubuntu. Now the container is not working anymore, so Docker container ls is listing me only the ones which are running. There is also Docker ps, which is an older way of this command. There has been changes on this, so I'm showing you both. You might find documentation saying Docker ps instead of Docker container ls. But if I do Docker container ls -a, I can have also the container that was stopped. So here it's telling me exited and 24 seconds ago. So now I want to access and start into that container again. So Docker start and my Ubuntu, the name of the container. Now Docker container ls, and we can access it again. What if we want to create our own image? I have here in my development folder, Docker messy circuits Ubuntu. This is an image that I created for the command line course that I made in a previous video. In that, I was using an Ubuntu distribution configured for what I needed for that particular course. A Dockerfile can be very complex. In this case, it's a very simple one. You have from, and then you specify the image that you want to base your image upon. In this case, I'm using Ubuntu as the based image, and it's going to download that from Docker Hub. You can have your own repository as well. Docker Hub, you can have private images if you pay, or if you don't, you can have it for free, but your images are going to be public. Be very careful in this step, because you have to download images from sources that you trust. If you don't, you can download an image that already has certain malware, or maybe just not even a bad intention, but some security issues. So be very careful what image you use, especially if you're going to use this into production. You have to be sure that those images come from a legitimate source. Then you have the run command here, which basically what it means is it's going to run all these applications, all these commands into the image before it's ready. So when you download this image, all of this is going to be created for you, and that image is going to be ready to use with all those commands already executed in it. In this case, I'm installing a bunch of applications that I needed for that course. So now if we want to create this image, we use Docker build, can give it a name like, and dot. Dot means this directory, the directory where the Docker file is. So Docker is going to find this Docker file, and from there it's going to build this image. It's going to take a little bit of time because it's going to download and install all the software that you saw previously in the run command. Then now what we can do is create a container based on that image. So Docker images, we have it here. So let's create a container for it. Docker run, and we are going to call this messy circuits Ubuntu based on the messy circuits Ubuntu EMG. Docker container ls, and here we have our container MC Ubuntu based on the image that we just created. I'm going to access to the container, and I'm going to run bash. This is the container running that image that we just created. And as you can see here, for example, I have things already installed, like Vim, that is not by default installed in that Ubuntu image, but because we create it and we install it as part of the configuration, we have everything we need here. This has been a very quick introduction to Docker, but the power of it is immense because, for example, I can just create my own application, program it in the way I want, in the way I like, test it, and when I'm sure that it works, I can pass it to a tester or somebody else, and I know that they will run it exactly the same way as I do. It's going to work in the same way. All the configuration that is needed, the packages, the libraries, everything. Those containers are light because they are reusing the operating system of the host. They are secure and also allows us to introduce to the concept of microservices, which means that you can have a big monolithic application. You can break it down in smaller pieces and transform those parts into containers that run that particular service. Docker is huge. There is even a certification about Docker, so I really recommend to learn it. It's a very useful tool that is a must know basically for any developer in the IT industry. I hope this video has been useful for you. I'm going to create more videos about Docker in the future, so stay tuned, subscribe, and thank you for watching.